Hello and welcome everybody to another episode of Paper Talks. Today we're doing a deep dive into something called the Stanford Emerging Technology Review 2025.
Okay.
It's a pretty dense report, but we're going to try to break it down for you. Basically, it's a deep analysis of 10 key science and technology fields, and it also looks at the broader themes that are shaping how these technologies evolve.
Right.
And of course, the big policy questions that come with all of this. So think of this as like a cheat sheet to understanding this really important analysis.
Yeah, it's not just about the technology itself, but how these advancements are going to impact society, the economy, and even global politics.
Exactly. It's a pretty influential report, too. These kinds of analyses often end up shaping national conversations about which technologies are considered critical, where funding for research should be directed, and how these fields get regulated.
It's important to look at the big picture, not just get lost in the details of any one technology.
Okay, so let's dive in. The report starts off by making a case for the vital role of academia in American innovation.
Right.
Why is that?
So basically, the report argues that the U.S. innovation system is built on three pillars: government, private companies, and universities. They're all essential.
Yeah.
But universities and national laboratories, they have this unique role. They do something called basic research, or sometimes it's called fundamental research.
And what's that exactly?
This is research that's really driven by curiosity. It's all about pursuing knowledge for its own sake, without a specific commercial goal in mind.
Okay, so it's not like we need to invent this product right now kind of research.
Exactly. It can take years, sometimes decades, to really see the payoff from this kind of work.
But I imagine the payoff, when it comes, can be huge.
Oh, yeah. Absolutely transformative. The report actually gives a bunch of examples of how this kind of basic, university-driven research has led to these major breakthroughs that have changed the world.
Like what?
Well, think about radar, GPS, the very foundation of the internet. All of those had their roots in research done at university.
Right.
And it's not just history either. Remember the COVID-19 mRNA vaccines? Seemed like they came out of nowhere, almost overnight, right?
It really did. It was incredible.
Yeah, well, that was actually built on decades of research done at universities. Research into how messenger RNA actually works within cells and how to deliver it effectively.
Wow. So decades of like fundamental science all leading up to a solution that helped us through a global crisis. That's pretty amazing when you think about it that way.
It is, and there are more examples in the report. The cryptographic algorithms that keep our online communication secure, those rely on decades of academic work in pure mathematics. Even the mind-blowing advancements in artificial intelligence we're seeing now, like these super sophisticated chatbots and incredible image recognition software.
Yeah.
Well, that's all built upon the pioneering research that happened in university computer science departments.
Those departments are also really important for, training the next generation of people who are going to lead in these fields.
That's right. They're educating the future workforce.
So essentially what this report is saying is that our research universities are like the bedrock of America's ability to innovate across almost every field you can imagine.
Exactly. They're the starting point of our innovation supply chain.
Okay. So after laying that groundwork, the report dives into 10 specific science and technology fields that it considers particularly critical.
Right.
What are those areas, and why were these specific fields chosen?
So after making the case for the importance of universities, the report takes a deep dive into 10 key fields. They are biotechnology and synthetic biology,
Okay.
cryptography, lasers, material science, neuroscience, robotics, semiconductors, space, sustainable energy technologies, and artificial intelligence. These fields weren't just picked randomly. They show up time and time again on lists of crucial technologies from all sorts of sources: government agencies, private companies, and the academic world itself. These are the areas that are seen as having the biggest potential to shape the future.
Got it. So those are the specific technologies under the microscope. But the report doesn't stop there. It also zooms out to look at some broader trends and patterns.
Right.
This section is called Cross-Cutting Themes and Commonalities.
Oh.
What are some of the big takeaways there?
Okay, well, this is where we start to see some really interesting bigger picture observations.
Oh, okay.
One key theme is about how technological discoveries actually unfold over time. The report reminds us that every new technology comes with both tremendous potential and also potential downsides.
Yeah.
Right? But what's really striking today is the sheer speed and scale at which these changes are happening. We're talking about things like materials being engineered at the nanoscale, which is a billionth of a meter.
That's mind-bogglingly small.
It is, and think about the incredibly fast progress in commercial space travel. This stuff is moving at an unprecedented pace.
It definitely feels like the pace of change is accelerating, like exponentially.
Yeah, and that has huge implications for how we think about policy. The report argues that technology policy isn't just the government's responsibility anymore. The decisions made by inventors and investors now have these big policy consequences, whether they intended it or not.
Like what?
Well, take the algorithms that are at the heart of AI systems.
Mm-hmm.
They embody choices about what outcomes are desirable and undesirable, right?
Right.
And many new technologies, whether it's some advanced medical treatment developed through biotech or underwater drones,
Yeah.
they have both civilian and military uses.
So private sector innovation is now deeply intertwined with public policy in a way that it maybe wasn't before.
Exactly.
Got it.
And private investment can certainly create national advantages. Like
Yeah.
it can lead to the development of new capabilities and supply chains,
Yeah.
but it can also create vulnerabilities, like dependencies on specific suppliers.
Yeah.
And sometimes, the goals of private companies, like making a profit, they don't always align perfectly with broader national interests.
Right.
The report also makes the point that this traditional model of how innovation happens, moving in a straight line from basic research to applied research to development, well, that's just one way that value gets created. Innovation often happens in these more complex, iterative ways.
That makes sense. It's not always a simple path from the lab to the market.
Exactly. And just because something is technically possible doesn't mean it's going to be economically successful or that it's going to be widely adopted. Factors like cost and ease of use are super important. The report uses the example of early superconducting supercomputers. They were amazing from a tech standpoint, but they were too expensive and too difficult to actually operate for most applications.
Okay, so just because you can build something amazing doesn't mean it's going to change the world.
Right.
Got it.
And we're also seeing private companies play a bigger and bigger role in driving innovation, especially in really critical technologies. This means we really need effective public-private partnerships and smart government oversight. The way AI research is being funded right now is a perfect example of how the landscape is shifting.
So it sounds like we need a more collaborative and adaptable approach to fostering innovation.
Absolutely. The report also cautions against something called frontier bias.
Mm-hmm.
Basically, it's this human tendency to overestimate how quickly and broadly a new technology will be adopted after some initial breakthrough. The report gives the example of nuclear power. There was all this early optimism,
Yeah.
but it hasn't seen the widespread adoption that a lot of people predicted.
Interesting.
And then there's the valley of death problem that a lot of startups run into when they're trying to turn their innovations into commercially viable products. They need a constant stream of investment, and they need to find customers.
It's a tough road.
It is. Finally, the report talks about the challenges of funding research. It points out that even when initiatives like the TCHPS and Science Act get authorized, the money doesn't always get appropriated. Meanwhile, other countries, like China, they're investing heavily in basic research.
So it's a competitive landscape, and resources are limited.
Very much so. The report then shifts gears a bit to talk about the things that enable and inhibit innovation. And it emphasizes that the heart of it all is ideas and human talent. We can't just manufacture those things on demand, right?
No.
And the U.S. is facing more and more competition, both at home and abroad, for that talent. The report specifically calls out U.S. policies that discourage immigration.
Okay.
It argues that those policies can hurt our ability to attract skilled workers, and that we could even see talent and R&D investment move to other countries.
So our immigration policies directly impact our ability to stay ahead in these fields.
That's what the report suggests. It also briefly touches on the differences between how innovation happens in democracies versus autocracies. Democracies tend to foster more open exploration. Autocracies can direct funding and focus more narrowly. Each approach has its pros and cons.
Okay, different systems, different strengths and weaknesses. Got it.
And then there's cybersecurity. This is highlighted as an ongoing concern for all areas of emerging tech R&D. There are constant threats, both from state-sponsored actors and non-state entities, to the confidentiality, integrity, and availability of data and systems.
Cybersecurity is like the foundation that everything else relies on, and it's constantly under threat.
Yeah, it's kind of invisible, but absolutely crucial.
Okay, so we've talked about some of the big picture trends and challenges, but now I want to dig into some of those 10 specific technology fields we mentioned earlier.
Sure.
Let's start with artificial intelligence. It seems like that's the one that's generating the most buzz right now. The report talks about AI as being this foundational technology.
Right. It actually compares its transformative potential to that of electricity or the internet.
Wow, that's a huge statement.
It is.
Hmm.
It's arguing that AI has the power to reshape societies, economies, and the political landscape on a global scale.
Okay, so big potential, but what about the risks?
Well, the report acknowledges that even the most advanced AI systems today can have these unpredictable failure modes.
Hmm.
And we often don't have true explainability, meaning we don't fully understand why an AI makes a particular decision.
Yeah, that's a little unsettling.
There's also a big debate about the best way to govern AI, whether it should be through strict regulations or more voluntary guidelines.
Okay, so how we control this powerful technology is still up in the air.
That's a big question.
Yeah.
And then there's the sheer amount of computational power needed to train these massive language models.
Like those chatbots we were talking about.
Exactly. The report gives this interesting comparison. For one company, it took a few hundred specialized chips to do some advanced AI work, while another company used hundreds of thousands.
Hundreds of thousands.
Yeah, so the scale of development is enormous. The report also talks about vulnerabilities like spoofing, where an AI system gets tricked by subtle changes to its inputs. Like there was this example where an AI mistook a stop sign for a yield sign just because someone put a few stickers on it.
That's scary to think about.
It is. There's also this rising use of deep fakes in politics, where realistic but fake videos are used to spread misinformation. The report mentions an example from elections in India where this was a big issue.
Right.
And then there are all these legal and ethical questions about copyright, especially when AI is trained on existing content. There have been lawsuits filed by the New York Times and the music industry against some AI developers.
Wow. So while there's this incredible potential, there are also a lot of really tricky ethical and legal issues to sort out.
That's right.
Okay, so that's AI. What about biotechnology and synthetic biology? What's the big story there?
Well, the report basically describes this field as having the potential to grow anything whose biosynthesis engineers can learn to encode in DNA.
Grow anything, like literally anything.
That's what it suggests. The report compares this capability to the launch of the first artificial satellite. That's how big of a deal it considers this to be.
Wow, that's pretty profound.
It is. And the report talks about these new, more distributed approaches to DNA synthesis, like enzymatic synthesis. These methods could make DNA production faster, more reliable, and more accessible. It also mentions this really futuristic idea of using DNA as a data storage medium.
DNA as a hard drive, how does that even work?
Well, it's all about encoding digital information into the sequence of DNA molecules. The report mentions an example where someone encoded a digital copy of a Herbert Hoover telegram in synthetic DNA.
That's wild.
Yeah, it's still early days, but it's a pretty fascinating concept. The report also talks about this growing trend of consumer biologics. Like they mention these genetically modified petunias that glow in the dark.
I've actually seen those.
Yeah, so it's starting to move beyond the lab and into everyday products. And there's this whole potential for biomanufacturing in space.
Biomanufacturing in space, what does that mean?
Like using the unique environment of space to produce biological materials that might be difficult or impossible to make on Earth.
Fascinating. But are there risks involved with this technology?
Definitely. The report raises serious concerns about the potential for misuse. Synthetic biology could be used to create harmful biological agents.
Okay, so it's powerful technology that needs to be handled very carefully. Got it. Let's move on to material science. What's new and exciting in that field?
Well, material science is kind of like this foundational discipline that underpins advancements in a lot of other areas.
Right.
And the report talks about how artificial intelligence is being used more and more to discover and design new materials and to figure out how they might be used.
So AI is helping us design new stuff at the atomic level.
Pretty much. The report explains that all materials are made up of atoms and molecules, but their properties can be wildly different. They use the example of table salt, which we all know.
Yeah.
But the atoms that make up salt, if you rearrange them in a different way, they can form a metal.
Real.
It's all about how the atoms are arranged. And then there's the nanoscale, which
Yeah.
we talked about earlier. That's where things get really interesting.
Okay, so remind me, how small are we talking here?
A nanometer is 1/1000th of a meter. So imagine something 1,000 times thinner than a human hair.
Okay, so super tiny. And what can we do with materials at that scale?
All sorts of things. The report mentions targeted drug delivery. where tiny nanoparticles can carry medicine directly to specific cells in the body.
Wow.
There are also energy-efficient smart windows that can change their tint to control how much light and heat they let in,
Cool.
and advanced batteries that use nanomaterials to improve their performance. But the report also points out that some nanoparticles can be toxic or pose environmental risks, so there's a need to figure out how to degrade them safely or recycle them.
So another example of powerful technology with potential downsides that we need to address.
Exactly. The report also notes that China is catching up to the U.S. in nanotechnology research. And there's this concern that export controls meant to restrict the flow of sensitive technology could actually end up hurting international scientific collaboration.
So it's a balancing act between protecting our interests and fostering innovation. Okay, let's talk about semiconductors. They're kind of the workhorses of modern electronics, right? What's the latest there?
Yeah, they're in pretty much everything these days.
So what's the report's take on semiconductors?
It starts by outlining the two main steps in how semiconductors are created. There's design, and then there's fabrication, which is the actual manufacturing. And it highlights how the U.S. has lost a lot of its manufacturing capacity for semiconductors over the past few decades. That's what its CHPS Act is trying to address. But it's going to take time to rebuild that industry.
So we're playing catch up on that front.
Yeah, we are. And the demand for semiconductors is only increasing because of all the advancements in artificial intelligence and machine learning.
Right, all those AI systems need powerful chips to run.
Exactly. And that's driving a lot of innovation, especially in trying to make chips more energy efficient.
So we need more powerful chips, but we also need them to use less energy.
That's the challenge. The report talks about Moore's law, which is this idea that the number of transistors on a chip doubles roughly every 2 years, which has historically led to cheaper and more powerful electronics.
Right, things keep getting smaller and faster.
But there are limits to how small you can make things, and there are challenges in trying to keep up that pace of miniaturization.
I see.
Plus, it's getting harder to transmit data using traditional electrical methods as chips get smaller.
Yeah.
So there's this new field called silicon photonics, which is about using light instead of electricity to transmit data within chips.
Light, that's interesting.
Yeah, it's a really promising area. And then there are all these advances in memory technologies, like 3D NAND flash memory is becoming really popular, and there are all these other new types of memory being developed. The report also mentions the importance of progress in quantum computing, which is this whole other area of computing that could revolutionize all sorts of things.
Quantum computing, that's one that's supposed to be super powerful and do things that regular computers can't.
Right.
Yeah.
So it's still very early days, but it has huge potential. And lastly, the report points out that a lot of semiconductor manufacturing is concentrated in Taiwan. And it talks about the geopolitical implications of that, which is a whole other discussion.
Yeah, it seems like having so much reliance on a single region for such a critical technology could be risky. Okay, let's talk about space. What's the outlook there?
Well, the report divides space activities into crewed missions, like sending astronauts to the moon or Mars, and uncrewed missions, like satellites and probes. And it mentions future crewed missions like the Artemis program, which aims to put humans back on the moon.
Right, I've heard about that.
But one of the really significant things that's happening in space right now is the dramatic reduction in launch costs. A lot of this is thanks to companies like SpaceX and their Starship vehicle, which is designed to be fully reusable.
So it's getting cheaper to send things into space.
Yeah, much cheaper. And that's opening up a whole bunch of new possibilities. There's a lot of interest around the world in establishing a permanent base on the moon, and maybe even starting to mine resources there. But the report points out that the existing rules and treaties for governing space are facing some challenges. Some of them are pretty old and don't really reflect the current state of space exploration.
Makes sense.
And in the U.S., there's no formal designation of space assets, like satellites, as critical infrastructure. The report also talks about the erosion of established norms in space, like those outlined in the Outer Space Treaty. It mentions a recent incident where Russia vetoed a UN resolution concerning nuclear weapons in space.
So there are some tensions brewing.
Yeah. And then there's the potential for dual-use technologies in space, meaning technologies that can be used for both civilian and military purposes. And the report even touches on the possibility of generating power in space and beaming it back to Earth.
That would be amazing if we could do that. So it sounds like we're entering a new era of space exploration and utilization with both incredible opportunities and some big challenges in terms of figuring out how to govern it all.
Absolutely.
Okay, last but not least, let's talk about sustainable energy technologies. What are some of the key insights there?
Well, the report defines sustainable energy pretty broadly. It's not just about generating clean energy, but also about transmitting it efficiently, storing it, capturing carbon emissions, and even removing carbon from the atmosphere. And one of the main points is that transitioning to a sustainable energy system and building all the necessary infrastructure is going to be a long-term process. It's going to take decades.
Yeah, that's a big undertaking.
It is. And the report says that in the near term, the focus needs to be on decarbonizing the electricity grid, which means moving away from fossil fuels and electrifying transportation, like switching to electric vehicles.
Okay, so those are the first steps.
Right. And a lot of clean energy technologies are becoming more affordable and widely available. But there are still big challenges in modernizing the existing energy grid. And getting everyone on board with the necessary policies can be tricky.
Right, there's often resistance to change.
Definitely. So the report talks about different energy storage technologies, because if you're relying on solar and wind power, you need ways to store that energy for when the sun isn't shining and the wind isn't blowing.
Yeah, that makes sense.
So they mention things like thermal storage, where you store energy in the form of heat,
Okay.
and advanced batteries that go beyond lithium-ion technology, which is what powers most of our devices today. And there's hydrogen, which can be used to store and transport energy.
Right, I've heard about hydrogen fuel cells.
Exactly. And then there's carbon capture, which is about catching carbon emissions before they get released into the atmosphere, or even pulling carbon directly out of the air.
Okay, so capturing the carbon that's already out there.
Right. The report points out that the U.S. electricity grid is currently very centralized.
Centralized.
Yeah, meaning that power is generated in a few large power plants and then distributed over long distances. But the report argues that we need to move towards a more distributed grid where power is generated in many smaller, more localized sources, and where the grid is more resilient to disruptions.
So kind of like a more decentralized system.
Exactly. And then there's nuclear power.
Which is controversial, of course.
It is. But the report considers both traditional fission reactors and the potential of fusion power, which is still a long way off. There are challenges with nuclear power, like the availability of specific types of fuel, the time it takes to build new reactors, and the long timeline for fusion to become commercially viable.
So lots of potential, but lots of hurdles to overcome.
Right. And then there are land use considerations for large-scale renewable energy projects. You need a lot of space for things like solar and wind farms. And it's important to engage with local communities when you're planning these projects.
So there are social and environmental factors to consider as well.
Absolutely. So it's a complex issue with a lot of moving parts.
Okay, so we've covered the 10 key technology fields, and we've talked about some of the broader trends shaping their development. But the report also looks at how these technologies intersect with different areas of public policy, right?
Yeah, it does. It talks about how these advancements have implications for things like economic growth, national security, environmental and energy sustainability, and health and medicine.
Can you walk me through some of those connections?
Sure. So for economic growth, the report highlights things like robotics and semiconductors as being really important drivers. And in the longer term, space activities and sustainable energy could play a big role in driving economic growth.
Okay, those make sense.
And then there's national security. All sorts of these technology are critical for national security, like AI, biotechnology, material science, neuroscience, cryptography, lasers, space-based assets, and of course, semiconductors.
So it's a pretty wide range of technologies that have implications for national security.
Yeah. And then there's environmental and energy sustainability. AI can be used to optimize energy use. Biotech can help with producing biofuels and cleaning up environmental contamination. Blockchain can improve supply chain transparency. Lasers can be used for environmental monitoring. Material science can make clean energy technologies more efficient. And, of course, sustainable energy technologies themselves are crucial for addressing climate change.
Right.
And finally, there's health and medicine. AI can help with diagnosing diseases and discovering new drugs. Biotech can lead to new therapies and diagnostic tools. Lasers have applications in surgery and medical imaging. Material science is important for medical devices and drug delivery systems. And neuroscience can contribute to treatments for neurological disorders and the development of prosthetics.
So it's really clear that all of these scientific and technological advancements are deeply connected to the things that we care about most, like our economy, our security, the environment, and our health.
Absolutely. They're not just abstract concepts happening in a lab somewhere. They have real-world implications.
Okay, so as we wrap up our deep dive into the Stanford Emerging Technology Review 2025, It's important to remember that these 10 fields aren't evolving in isolation. They're all interconnected. And the broader things we've talked about, like the importance of academic research, the challenges of funding, the need for talent, and the ever-present threat of cybersecurity, they're all shaping how these technologies develop.
Yeah, and the report really stresses the importance of American leadership in navigating this era of rapid technological change. We need to be proactive in shaping how these technologies evolve and ensuring they're used for good.
That's a great point. And I think it leads to a really important question that the report prompts us to consider. Given that a lot of these technologies have dual use potential, meaning they can be used for both good and bad purposes,
Right.
and that different countries are approaching innovation in different ways, what are the ethical and policy considerations that we need to be thinking about, both as individuals and as a society, to make sure that these advancements ultimately benefit humanity as a whole?
It's a big question, and it's one that we all need to be thinking about
Yeah.
because the future is being shaped right now,
Yeah.
and we all have a role to play in shaping it for the better.
Well said. If you're interested in exploring these ideas in more depth, we highly recommend checking out the full Stanford Emerging Technology Review 2025 report. It's a fascinating read. Thanks for joining us for this deep dive on Paper Talks.